Ready to get started?
Absolutely. Let's get this
Awesome.
party started. So, good afternoon, everyone. For me, it's a little bit later, but we just had a quick look on YouTube and we're already seeing quite a few of you trickling in, so that's super awesome. Thank you for being here today and on Discord and in our DMs and everywhere.
Oops, I was taking a sip of my drink, but hello. My name's Jacquie, and I'm working as a developer advocate at HashiCorp. A little bit more about me before we get into this is I'm one of Canada's top 30 under 30 developers, which is pretty cool. I think it's cool. And over the last 5 years, I've been working as a DevOps engineer, mostly in the digital healthcare space. Oh, I just got scared. I saw the comment, they can't hear us. And I was like, oh, but they can hear us. It's okay. So coming into this, I'm pretty excited to be doing this workshop. I think hackathons are an absolutely wonderful place to push your boundaries of your comfort zone, discover new opportunities, and just try new things. I was really excited about my last one where we basically hacked together a video game in 2 weeks and then got the opportunity to go speak about it to over 10,000 people, which I'm still like, wow, I can't believe that happened. And I'm also going to be one of your judges for this event. I'll be judging the startup track and the video gaming track. So yeah.
That's super exciting.
I think so too.
Yeah, that was a pretty cool game you built there. We should share the link for that. I mean,
Oh no.
people like Animal Crossing, right?
Yeah, true. I built a game and then I talked about it in a game. If you want to get in touch with me, my Twitter handle is DevOpsJacquie, and you can find me on GitHub at GoGoCoco. And just again, I'm a developer advocate at HashiCorp. So.
Hello again. My name is Kerim Satirli. I've been working in IT operations and automation for the past decade, so I'm really old. And unlike Jacquie, I'm not a developer that's in the top 30, but I am a developer advocate at HashiCorp, and I mainly focus on Terraform. So that's what we'll be talking about today. Obviously, if you have any questions, either during or after the presentation, you can find me as K Satirli on Discord, GitHub, Twitter. Many of you have already found my DMs, so that's cool. Really good questions, and absolutely reach out if you have questions with AWS. I'm happy to help. Jacquie's happy to help. And there's a couple more mentors on there.
So let's have a look at what we're going to be getting into today. First up, we're going to talk a little bit about infrastructure as code and what even is that? It's knowledge that's going to oops. It's knowledge that's going to help you out not only for this workshop but in your future with building things and making it reliable. Then we're going to be provisioning our first resources inside of AWS, and we'll be taking a look at how we can connect multiple infrastructure resources together. During this workshop, we're expecting to set up an EC2 instance. I say expecting like it's not going to work. It's going to work. We tested it. But setting up an EC2 instance and an S3 bucket. So that's if you need any kind of workloads, or if you wanted to put a static website up, you can put that in S3. And we've also put together the basic security for you to be able to deploy your app and make sure nobody's going to take it. Stuff like that. That was a bad sentence. Anyway, and finally, we're going to be talking about some more advanced use cases and learning resources. This is the stuff that you might not need today, given that it's a pretty short hackathon, but you can definitely make use of it, and it'll kind of be what your next steps are and taking you forward with it. Some of the stuff we'll talk about in that section is also meant for you to use when you just really want to go further or you have more cool things you want to build.
Thanks, Jacquie. Yeah, those things are definitely going to be helpful, not only as a basic understanding for today's workshop, but also for your next hackathon. Because obviously, the more you know, the easier your hackathon gets. And that's all about pizza. So in today's workshop, we'll be talking about infrastructure in the IT sense. So servers and the applications we can run on them, as well as the configuration that's needed. And any associated resources, such as databases, firewalls. More specifically, we'll be approaching infrastructure from a code perspective. So infrastructure as code, or IAC if you're lazy. The process is the process of managing and provisioning resources with machine-readable definition files, as opposed to just going into an interface and clicking things together, which works great the first time, maybe works great the second time, but doesn't always work. So when we talk about resources, in our case, we talk about virtual machines, we talk about security groups, as Jacquie mentioned, network and software-defined storage options. Lots of fancy words for essentially what's a computer in the cloud. When you think about infrastructure as code, you can think of it as any other programming language. It's executable documentation, right? If you write code that's human readable, a computer can interpret it, but you should also be able to read it, and therefore it becomes documentation. So with this workflow, you're writing code, you end up essentially having plain text files, which you can commit to your Git repository, if you're that kind of person, your SVN repository. But because it's code, because it's committed, everything you do with version control applies here too. So you can collaborate with your teammates during the hackathon. You can roll a change back when things go wrong. I think we might have a story or two about that. And you can roll forward when you realize that the thing you thought went wrong didn't actually go wrong, and you made it worse by rolling back.
So infrastructure as code is pretty cool. I say that kind of flat, but like I actually worked with it for the last 4 years before I came to work at HashiCorp. So this is something that was really exciting for me about joining here. The things that Kerim mentioned are really important because they'll allow us to try new things, but also have faith that the state that we built before is still there and it's going to work as we expected it to. We've talked a little bit about infrastructure code as code, and we've been throwing this around a bit, but what language even is that? When you're writing code for Terraform, we generally use something called HCL. What that stands for is it's the HashiCorp configuration language, which is a common language that's supported by all of our tools. And let's take a look at what it looks like. In this example, we have a resource and it's called service. So you can see it on the top there. And it has a single key value item. We're keeping this really simple for now just to try and show how it looks, but the service item could have many more key values that define different attributes depending on what we're doing with it. A more involved example would be something where we have a named service, and we're going to go with the HTTP service this time. We then name the resource web proxy, and we're going to add a key value to define the listen address. Then we add another object, and that's to define the process that we're putting a proxy on. So we provide a command, and that's going to get run with an argument. In our case, the application is called proxy app, and the argument was server there. So what's really cool about this is HCL is both human readable and machine readable. It's JSON compatible and it's supported by all the major code editors and IDEs. So you can get plugins for whatever you want, whether it's, VS Code or Atom or Golang. And the syntax is something that you can pick up in just a couple hours, which is really important. And it's really nice to be able to just kind of have that and look and understand it. So say you're writing a lot of this code and you want to use some kind of template structure, probably. Something like a variable, maybe, so you don't have to repeat yourself over and over again. And more importantly, you don't have to hard code everything. For those cases, you'd want to use the variable syntax. So let's go ahead and define it. It's a new variable. We'll call this one port. And we'll give it a default value of 8080, the same thing we did for the service above. Personally, I like to add a description to every variable I define. It makes it easier to understand what the variable actually does. Funny thing about this is actually a point of contention with me and one of my previous teammates. I don't think he's watching, but I'll tell him later anyway, where he would always strip out the nouns in some of the words. So we'd get things like SVC, and sometimes you'd get these put together and it'd be really hard to understand what it was for. We got better about naming conventions, but we also got really good about adding descriptions to try and help us along.
Descriptions definitely help.
Yeah. And then next up, we're going to update the web proxy resource, and we're going to change the listen address from the hard-coded value to a dynamic one. We do this by adding just a little bit of code, and voila, listen addresses now contains a value that is dynamic and will change whenever I update the value of the variable. In the port definition below, oops, there is a speaker note problem.
I was too quick.
That's okay. I didn't realize that sentence continued, so it actually sounds like I'm going to continue to say stuff, but actually I'm done. Surprise!
Sorry, I clicked too quickly. I think the thing we should have said is that the port variable below, so essentially in line, I think 16, if I'm counting this real quickly, is the same value that we have on line 2. And so Terraform dynamically retrieves this value. But yeah.
That was a lot of code slides, but I promise it's going to be really useful to just have that context to build on for the next part of what we're going to talk about.
Is it a pinky promise?
It is a pinky promise. I even have like a little shiny ring to show that's my pinky.
I mean, you're right. That was definitely a lot of theory, but it will be helpful. So Terraform is an infrastructure as code application that supports a wide range of external services. To do so, Terraform uses what is called a provider. Each provider is responsible for understanding API interactions for a specific service and then makes those interactions available to you. So let me give you some quick stats. HashiCorp, the company we work for, maintains around 125 official providers. We've got stuff for AWS, Azure, GCP, Docker, Kubernetes, and many, many more. And then there are roughly 175 community maintained providers for services such as Auth0, the Sentry CI service, and even Domino's Pizza.
Pizza is essential to every hackathon, even virtual ones.
It definitely is. I feel like we should have just ordered us pizza, right? And
I
make
had
sure
pizza
it
last
arrives.
night. I just didn't tell you.
See, this is the problem with virtual hackathons. You don't get to share pizza. But pizza, yes.
So that's pretty cool. But what do we do with those things we talked about earlier? How do we actually use them?
Well, why don't you show us?
Ooh, table turns.
You got the pizza, so you get to talk about it.
All right, well, first step, let's get started. So we've structured today's session in a way that we'll be looking at and explaining the code. You can code along if you want to, but the finished code is also published as a public repository, and you'll be able to take a look at it and use it. I'm realizing I meant to share this at the beginning, so the next time Kerim talks, I will share a link to this. And you can check out the Discord and in the hashtag AWS Workshop channel to talk to us and stuff like that. So in our code editor, we start by adding a provider. In Terraform, you define providers with a name block that identifies the provider type. In our case, we're going to be using AWS for Amazon Web Services, but it could be Google or it could be any one of those other like greater than 100 providers. We start with the version. In this case, it's 2.65. And then we also set a region where we want our resources to be created. For this workshop, we've targeted US East 1, even though that's not my region or Kerim's region. But given Hack the Northeast is based in that region, we figured a different one, or that this is the right fit for this one. But if you're like us, you might need a different one to be a better fit for you. Moving on, let's talk about...
because I think...
Sorry, go.
Sorry for interrupting. I just realized as I was watching the Discord, I actually saw a couple people from Germany, India, like people are here from all over the world. So while we have US East 1 in here, obviously pick the zone that works best for you. That might be Frankfurt, that might be the Mumbai region. AWS has zones everywhere. Use whatever makes sense for you. But the thing I'm wondering is like, how do you actually connect to that?
Well, there's a few ways that we could go about doing that. Yeah. So we can add the credentials inline and just hard code them there. Or we could define them as variables.
That doesn't sound like a good idea.
I know, I was like, I didn't actually see the face I made, but I'm sure it was great. So hard coding credentials into your Terraform code is really not recommended. You could accidentally leak the credentials if you commit your code. So that'd be something like, oh, I've committed my credentials into GitHub, and now anyone who can see my repository has my credentials, so they can use my account to provision up infrastructure, and then I pay for it. So that really sucks. But let's go ahead and define them as variables.
Definitely a better idea, because I've had that situation.
Oh no.
Super awkward the next day to talk to your colleagues about that.
The absolute worst is when you purge credentials out and you're new to the job and you're like, I'm going to purge these out because this is not a good practice. And it's like, GitHub, Jacquie has committed 8,320 changes. True story. I was terrified. So you go back, you write history, it's bad. It's not a good idea either. But anyway, defining them as variables. Sorry. So oh no. Sorry, where are we? Yeah, here.
You want this one?
I don't know. Now I'm lost. It's weird. Kerim actually has the slides today, so I'm used to hitting the button. I'm kind of like, oh no. But it's all good, it's good. So yeah, another option would be to define our access key and our secret access key as environment variables. That's so we don't commit them. Using this approach, we don't have to hard code any of the credentials into our code, so we can also post the rest of that code that is probably useful and people need without worrying about that.
I like that approach.
Me too, me too. And then switching from our code editor to our terminal, I'm going to show you how to initialize a provider.
What terminal are you using for this?
Well, in this case, we have a pretty terminal in the slides, but normally I have a like ZSH shell set up, and I use iTerm too.
Nice.
If you're going somewhere else with that, I totally missed it, my bad.
Nope.
Perfect.
ZSH.
Nice. Yeah, so to get started, you'd use the init command in your terminal, so Terraform init. And you can kind of think of this the same way you do with get init. What it does is it creates up a private Terraform directory. I wrote repository, and that is wrong, but it puts up a private Terraform directory that then kind of sets up your space and is like, hello, I'm a Terraform directory, we can use Terraform now. And Terraform init is a helper command. Oh no, I said some of this already, but it sets up your local directory with the right binaries for all the providers that you configured. And in our case, again, we're using the AWS Provider.
So for today, we've created a provider and we've supplied API credentials, luckily through the environment rather than actually just hard coding them. And we've successfully executed Terraform init, which to be honest, all of this it's super important stuff, but it's boring stuff because you don't get to see anything. You don't get to see in a console something that's happening in the AWS console. So why don't we create an EC2 instance? And like Jacquie said before, Terraform has variables. So we'll start by defining a few variables. When you start an instance on AWS, you supply your choice of operating system. So that could be Windows, that could be Linux, could be any other option that's available. In our case, we're using Amazon's Linux, freely available. And we just define the AMI ID for this. And so what you see here is that I'm hard coding the ID value here in my variable, but not in the resource, as you'll see later. And this is fine because when Jacquie looks at my code, she can see that this was the AMI ID we used to start our service. And that also makes rolling back a lot easier. We've both been in hackathons where essentially you're like high speed, low drag, things go wrong, and you're like, wait, I know this worked 3 hours ago and about 7 Red Bulls ago. And all of a sudden, you're like, wait, I can go back in my code. One thing to note, we built this for the US East 1 region, and the AMI ID is valid for this region. If you're running this in Frankfurt, the ID is going to be different. But we can probably show you something in the AWS workshop channel later on how to get the ID for your region. So we've defined the AMI ID. Next thing we want to define is an instance type, which allows us to say we need a server that has In this case, a couple hundred megs of RAM, because we need something really simple. But obviously, depending on what you do, you might want to have like a really beefy machine. So if we go through our code a little bit, scroll up, we'll add another variable for availability zone. And that's essentially defining where exactly in US East 1 your server will reside. There's a whole lot of theory behind that, but generally the A zone is available for most of them. So that's what we're going with today. If you really want to know how this works, feel free to ask in the channel. We'll happily dive deep. So let's save this as a variables.tf. We'll create a new file, call this instance.tf. And same as before, we define a resource, and this is of type AWS Instance, and we name it Hector Northeast or Hector NE. And so let's populate some of the values in there with the variables we just defined. And so at this point, with 5 lines of code, if we run this through Terraform, AWS will create a new server for us. It will be bare bones, but it will start up in the region we defined, so US East 1A. It will be a T2 micro instance, and it will start with the Amazon Linux image, which is pretty cool because this is about as much as you need for a CSGO server. And I know this because I've done this 5 years ago, exactly like this. So question, of course, is how do you get this into Terraform? And if we switch back to our terminal, we'll use a Terraform plan command. And in our case, we specify Terraform plan with the out argument to write what's called a plan file. And if you're taking part in hackathon, you know, like if you're in the startup track, you're actually also writing a business plan. And you can think of the TF plan command, the TF plan file is pretty much that. You're specifying what you want to achieve. And that works pretty well. And Terraform is helpful because it shows you that these are the changes it's going to make. Now, obviously, an instance or a computer in a cloud has more than one attribute. So we've stripped out a lot to make this a little bit more readable. Because despite us only needing, was it 5 lines? AWS will actually send back, I think, 70 different attributes. You'll see them if you run the code yourself, but they're not in here right now. What is in here right now is that our plan was saved, which means Terraform didn't encounter any errors, and that's exactly what we want. And that means we're ready for the next step, which means we can apply the file. And this step usually takes a little bit, because what happens is Terraform, which is running on your computer, is making a web request to the AWS API, and it is instructing it to start an EC2 instance. You got to imagine that AWS is continuously running servers, but they're not always associated with your account, which is a good thing because, as Jacquie mentioned before, if that happens, you end up paying a lot. So in this case, 10 seconds in, and here we go. Our instance, after 22 seconds, was created. That's a lot faster than I could order gaming PCs from past month. I think yours also took a lot longer than 22 seconds, if I don't misremember.
Took a few days, and some things took a couple of weeks to get in, but they made it.
Yeah, they definitely made it. So if we quickly switch to our browser, you can see a running EC2 instance. And I think the beauty here is that all of this is defined as code. So despite me standing here in Amsterdam, Jacquie being in Toronto, we could just easily share those text files, and she could create this exact same instance in her own account, and it would look the same, behave the same, and be connectable in the same way. But of course, when you have a server, you also want to store a lot of data on there, usually. I think somebody in Discord had a question on like, hey, what's a good file storage API? We need to upload 50 gigs. And most of the AWS instances don't have that kind of space. So I'm wondering, Jacquie, maybe you want to share something about storage?
Yeah, I could talk about storage. So we're going to talk about volumes, or EBS volumes. But before I go into that, just kind of start throwing AWS words at you. You can think of volumes as something like external storage to your computer. So it's kind of like how if I have my laptop and I wanted to be able to store some extra files, or maybe I want to be able to take them and move them to my other laptop, I could plug in like an external hard drive or a USB key, and that would give me removable storage. So an important part about that is the removable thing. If I kill the instance, it doesn't necessarily kill the data. And EBS volumes are storage claims that you can attach or detach to your EC2 instances. So here's kind of a fun thing we can show you. When you attach a volume via the AWS API, the EC2 instances system doesn't know about the volume yet. So we go ahead and we define an output in Terraform, and that allows us to get some more information about the volume out there. In a new file, this is outputs.tf, we create an output and name it volume device name. Outputs have a similar syntax. So what are you saying?
No, it's a boring name.
Yeah,
it's way too long.
And outputs have a similar syntax to variables. So if you think of the variables as inputs, it makes a lot of sense. And then we go ahead and we add a value of key. Oh, a key of value. I just reversed words in my head, which was not the most choice words to reverse by accident. We add a key of value. There we go. I know it sounds confusing. I just confused myself reading it somehow. And we populate that key's value with the interpolated value of the device name of the volume attachment that we have. There should be something along the lines of /dev/SDH.
You said this is the interpolated value. What does that even mean?
Oh, wow. Why don't you tell me? Mister, I'm jumping in.
I'm sorry. So what you see here in the second line of our code where we have the value, we're essentially telling Terraform, look for a resource of type AWS Volume Attachment. And then we want it to be named Hack the Northeast, which you can see in orange or yellow, depending on how you configured your screen. And then we want the specific attribute called device name. And that's what Jacquie means with /dev/SDH or SDA, depending on your system.
So if we go ahead and apply this, it's first going to render the value. And then Terraform refreshes its state file, and it checks for any changes that might have been made, and then it finally outputs the newly defined output. This is useful when we run it through Terraform, but sometimes you need to consume an output directly. Maybe you're writing another script and you need to know something about Terraform's output. For this, you have the actual Terraform output command. This is going to print all the outputs after you've completed a Terraform apply run. It's really useful for scenarios like, I'm going off script for a second here, but I've been working a bit with trying to set up Nomad and console and things like that, and it's been really useful to have these outputs and to be able to run the output command for a couple things. It can give you like your SSH paths if you need to go to the different machines, and it can also do things like tell you the IP address and the port that's running of this machine if you configure it that way. So that way, if Kerim was to run my code, even though maybe he ran it somewhere else and it's got dynamic IPs or changing IPs, he'll still have the exact connection string to be able to do it.
That's beautiful.
So moving on, if you're doing it, oh wow, okay, I just had a brain blank. I knew it was going to happen today. You need to be more specific with Terraform, and you need to supply the output's name. So here we go, and it's our value ready for consumption in a script.
So we've actually experimented a lot, and obviously building up this workshop, I think we started probably like 30 servers, and we terminated most of them again because, we have somebody that gets angry if we leave them on. So let's talk about how we can terminate our resources. And to me, that's always such a nice word, right? Like you're building something up and then you get to terminate it. And Terraform has a command for that, which is called destroy. And it literally destroys any infrastructure that Terraform repository manages, which is very powerful. But it's also useful because AWS resources cost real money. You might be getting a credit voucher if you, for example, sign up through the GitHub Education Pack. And you get, I think, like 50 or 100 bucks that you can use to run your own servers. But once those are gone, you'd be the one paying for them. And at the end of the day, well, you shouldn't be wasting those resources. So just like with the apply command, we first want to see what we're removing. So let's use the Terraform plan command again, which we had a couple minutes ago. But this time we'll add -destroy to the end. And what this does is it will generate an execution plan of resources that will be removed. And if you remember a couple minutes ago when we talked about Terraform plan, those TF plan files are essentially promises of what Terraform will do for us. So as before, super simple, we can apply this execution plan by running Terraform apply and appending the .tf plan file. And in our case, that's aws.tf plan, but you can name this whatever you want. And it will take a few seconds or minutes, depending on how much data you have in there. And Terraform will slowly start removing all of your resources. And you can see it started by destroying your EBS volume. Next was the instances, the volume attachment, and here we go. 3 resources destroyed, 0 added, nothing changed. And we're no longer paying for these, which I think is beautiful.
So in the real world, I would have just typed all this code out. I might have messed up the spaces or the indentations, or honestly, it might have been one of those things where like, ain't nobody got time for this. I'm trying to get this code out there. I'm trying to get production running. I don't want to sit here and hit space like a bunch of times or tab to get things right. But the good news is that that's okay because we have this thing called Terraform. I'm just kidding, it's format. So let's go ahead and format and validate our code. Running this, what it does is it cleans up and formats the code according to the internal rules that are set for it. So again, it will kind of align your indents, it'll move things around, and make sure that it's really easy to read the file afterwards. If you write Go, you can think of this like Go format, Go FMT. Now I'm messing myself up because I wanted to be like, and I was like, no, Jackie, stop. This kind of linting is really good, and it ensures that everybody has the same code structure. And next up, we use Terraform validate to validate the code we just wrote, which is it's nice. It tells you if there's any obvious mistakes in it. What it is it's a sanity check, and it verifies the configuration files, but it doesn't actually have any access to the remote APIs or services. So it won't catch things like if you've got something wrong on the side that would actually be using the cloud. That's not my best example yet. But our recommendations would be to use validate often. So Terraform has a really large number of CLI commands, and you wouldn't really use all of them all the time. So if you're ever stuck, you can just use Terraform help to find out more about a specific command and what it does. I've also got a ton of documentation.
There is definitely a ton of documentation. I mean, I've been using Terraform for the past 6-7 years, and I'm still using Terraform help just to make sure, oh wait, am I using all of the arguments I want to be using? Am I, hitting all the right things? And yeah, format, validate, those are definitely really, really good things to keep in mind. Because no matter how good you think your code is, Terraform is always there to essentially help you a little bit and look over your shoulder and go like, hey, you should probably indent this a little bit better. So we've talked a lot about the basic stuff of Terraform, but we haven't really put all of this together. So let's talk a little bit about the Terraform lifecycle. And maybe later we'll talk about Terraform State. So as Jackie mentioned, we talked about Terraform init, which is the git init of Terraform. We use this to set up our provider. And we showed you the AWS provider, but if you look at the code that we'll be sharing in the AWS workshop channel, you'll see that we use the AWS provider, the TLS provider to generate private keys. We use the HTTP provider and a local provider to render files locally. There is definitely a lot going on here. Then we wrote some code and we made sure it's clean and nicely formatted. And as Jacquie said, we use the Terraform Fmt command, or FMT, if you pronounce it in European English. And then we followed this up with the Terraform validate command. Next, we generate an execution plan. We actually did this a little bit earlier to show you some of the more exciting stuff, because realistically, the cleaning work of FMT and validate is never really exciting. But your actual lifecycle should definitely be init, format, validate, plan, to see what's going to happen and to make sure your code is ready to play. And we saved our execution plan to a .tf plan file. Everything looked good, so we did an apply. And then once we were done with either a hackathon or just playing around with a server in the cloud, we used the destroy command. So that's pretty much how the basic Terraform lifecycle looks like. And so Terraform generates files for you. You've got the .terraform directory, which stores your providers, and Terraform will just download the right version for your operating system. So that might be on a Mac, that might be on Windows, that might be on Linux. Terraform will just figure this out for you. And in the README of the repository we're sharing, we've got installation instructions for all operating systems. So you can just run this easily. And that's, I think, super nice. When you run Terraform, especially after doing the init and trying your first resource, Terraform works with something called state. And so what state really does is probably something that you could talk about.
It is.
I need some water.
So the state file is, it's really great. I learned about it through the mistakes of not using state files properly. So we're going to try and talk a little bit about the basic level of it, and then we're going to give you a couple tips, I think later, about what to do. What it does is it keeps track of all of your resources and the state that they're in. So if you say create a couple machines and they're there, maybe you want to make them bigger, or you don't have enough machines, or you want to make some changes, it compares the state of what's there to what you have now. And it uses things like provider identifiers, image tags, volume mounts, and a lot more to kind of make sure that it's building what you want it to build. More important later on is that the state file also helps to keep Terraform performant when you have very large scale infrastructure. Because sometimes we see people using this with thousands of machines. I haven't done that yet. But by default, your state is stored locally. Oops.
Sorry about that.
It's okay. But yeah, by default, your state is stored locally, and it's in a file called Terraform State. Terraform.tf state. There we go. This approach is fine if you're the only engineer working on a project, but we really recommend storing it remotely. So that's in the code samples that I'll share with you later. I've also included, well, we've included some more reading material on how to store state remotely. You want to do remotely in the case of maybe we're working together and, I've made some changes, and then Kerim needs to be up to date with those changes and wants to make it work. Some of the things around state is, is it security group story or is it state story? I have both.
There's definitely a state security story, which is people committing state files to public repositories. And it kind of takes us back to what we talked about before, right? So essentially, you've got secret credentials that may end up in your state because you hard-coded them. And now all of a sudden, you're like, hey, I want to show my GitHub repository to the world. So you click that button that says make a repository public. And GitHub still goes like, hey, are you sure? Yeah, of course. please enter your password. So you enter your password, and about 3 to 5 minutes later, either AWS or GitHub will send you a nice email saying, hey, you are sharing your credentials. And that's a bad thing. And that is the exact reason why we recommend putting your credentials into environment variables. Because that means the only person or only someone with access to your computer can extract those keys. And we don't want that.
That'd be bad.
So if you're not leaking credentials, there might still be other bad things happening. I think you mentioned that you had a mistake story.
Yeah,
like
I do.
A learning moment, I guess.
A learning moment. They're all learning moments. But talking about
There's
security
so many.
groups. So I remember, I'm going to try and keep this one short because I can do this one pretty long. But basically what happened was when I was really new in the industry, I was the only person doing ops and I was the only person making the things. And what we'd been doing previously was kind of remotely connecting to the database. You probably already know where this is going because we're talking about security groups. But we were remotely connecting to the databases. And I read somewhere on the internet that like, wow, you should have like restricted security groups because it's really bad if they're open to the internet. And I talked to my team about it and they're like, yeah, that sounds good. So we restricted the security groups. And then my dev team was like, oh, now we can't connect to the database, so we can't run any of the migrations that we need to do. Can you just open those back? And when we know how to fix it properly, we'll fix it. That is the correct face to be making. So I did roll it back. And what happened was it was a Mongo database. And what happened was there was this the script that got leaked at some point, I think it was around 2016, where it was just connecting to a bunch of MongoDBs, dumping out the data, and then replacing it with a file that said something along the lines of, your data has been like ransomed, send Bitcoin to this generated email to get your data back. And yeah, I thought I was gonna get fired, I'm gonna be honest. I was like, this is the day that my career is over. It was not the day my career was over. Production was fine. Every other environment was not fine. But that's kind of the day I learned about security groups, where if I had just set something so that our devs could connect to it, but not the whole internet, we would not have had our data ransomed. And yeah, I wouldn't have been scared of losing my job. So yeah, moving on to security groups.
Yeah, 2016 was a good time to ask for Bitcoin.
Oh yeah, it was a great year.
Yeah.
Lots of learning opportunities.
Yeah, protecting the innocent definitely didn't happen in this example, and that's cool because I have that exact same story also with that kind of database type. Except for us, it happened after spending 3 days importing multiple terabytes of text files.
Oh no.
And then, eventually you want to go home, right? Because, well, we were doing a company hackathon, which really just means that you're spending 72 hours at your office, which people don't do anymore because nobody goes to an office. We're all just home enjoying our dinosaurs on our t-shirts or geese. And essentially, you get tired, which happens during a hackathon. You're out of energy drink, the pizza is cold. You couldn't order new pizza because Terraform didn't support that back then. And you realize that, you know what, I'm just gonna go home and I'll work with a security group from there. And, you could say, I'll open this for my office. You could say, I'll open this for my home address. But when you're tired, you open it for the world. And the exact same thing happened as with Jacquie, except for us. Nobody asked for the Bitcoin. They just went in and deleted everything. Also super cool. Yeah, good learning moment. We improved a lot. Next time it only took 2 days, not 3, which percentage-wise, super good. Still very frustrating. Let's talk about security groups.
Let's.
Definitely going to be helpful to prevent that kind of mistake. Learn from us. Don't waste your time on restoring things. Just protect them from the get-go. And yeah, use security groups for that. And so you can think of security groups as firewalls or gatekeepers, defining who can access your server and who cannot. So if we have a look at security groups in Terraform, I'd like to specifically look at the security group rule resource. And we'll build one that will allow you to access your own server, but won't allow me to access your server, or anyone else for that matter. You definitely don't want to have Jacquie on there, because the last time I gave her access to my server, I ended up having a Minecraft server on there, which was cool at first and a little bit unhelpful later.
I think you said Nick wrong.
Yeah. So, see, this makes me think about your colleague that wasn't super good with adding descriptions. I think we'll start by adding a description, because that way, down the road, you'll know what this group does or what this rule does, both by looking at your Terraform code, which right now is 3 lines, but don't worry, they'll get a little bit longer. But you could also be looking at the AWS console, and you'll see it there. And so next, we'll define the type of the rule. And in this case, it's an ingress rule. So something that defines what can come in. This could also be an egress rule, so defining what can go out. In our case, we just want to make sure that we can get in. So with firewalls, you generally define a range of ports. That could be, 80. So from port 80 to port 80, so literally just one. But in our case, this is a hackathon. Some of you might be coding in Node and using one of the default web server packages that end up on port 3000, port 9000. You might be doing something else that ends up on 8443. It's a hackathon, so make it simple for yourself. Just open all of the ports. And this is important, just open them for yourself. So next, we'll define a protocol. And finally, we'll define who can access these ports. And that's a really important part. And in AWS, you do that with CIDR blocks. And there's a whole lot of network knowledge and theory that goes behind understanding what happens here. But at the end of the day, as long as you put your IP address in there with the /32, then you're essentially limiting this to your computer, as long as your computer is the only one that has the access credentials. So we've done variables, we've learned about HCL, we've had multiple providers. So I'll use a little bit of functional magic here to figure out a way to get an IP address. And so what you can see here is I'm using a data source for a website, and you can see this if you don't believe me, which nobody ever should, because it's called HEP. And so the HEP data source makes a call to icanhasip.com, which is a great site to get your public IP address. Works great if you are somewhere else and you just need to get that IP address. If you're hanging out at your parents and they don't know what their IP address is. I swear my mother couldn't tell an IPv4 from an IPv6. Sad. And last but not least, when you retrieve that IP address, we just throw it into a function, which is called chomp, and do some magic with it. And so again, what this does is it retrieves my IP address when I run it. And if Jacquie runs it, it will retrieve her IP address.
Say that again, because I was muted. That's pretty cool. So, carrying on.
Yeah, that definitely covers pretty much all that we wanted to talk about for today. So Jacquie, do you want to maybe review this?
Yeah, I could do that. So, we started out by explaining a little bit about expressing your infrastructure resources as code and what that meant. And then we introduced you to Terraform and how it fits into an infrastructure as code world.
And then, honestly, came the most exciting part for me. We deployed our own server, which is a pretty good afternoon, I'd say.
Absolutely. It's a lot more productive than my regular Saturdays are. So if you want to have another look at the slides later today or whenever, you can go to hashi.co/htne-slides. Or you could just look at the slide, and that's probably an easier way to type it.
That's definitely an easier way.
Yeah. And if you want to try the things we showed you today with your own AWS account, you can take a note of the second link that's shown here. I've also dropped in our repository link in the YouTube chat and our Discord channel for the workshop. There you'll be able to find the actual code, and we've put in a bunch of reading material that we think will help you out, as well as like your pre-steps, what you need to install, and hopefully anything else you would need to be able to run this.
Yeah, indeed. We built some code for you. We made sure it works, and essentially everything that we built in there builds upon what we showed you in the past hour as part of a workshop. And so you should be able to get your own private server started easily with that. If there's READMEs, you get a private server, you get a SSH key. You don't have to supply anything other than your AWS credentials. And, oh, right, we also added an S3 bucket with a website config. So if you happen to be building a web application that just needs static files, that's cool too. And then you get that as part of the workshop. If you want to learn more about this, and I absolutely recommend doing that after the hackathon, you could go to hashi.co/tflearn, which will take you to our listing of guides on how to use Terraform and our other tools. And if you use the link that just popped up, you'll be taken directly to the Terraform section.
And finally, from June 22nd to June 24th, we're going to be organizing the very first digital edition of HashiConf. Kerim and I are both going to be TAs for some of the workshops that are there and happening, and there'll be tons of really good talks. Registration is free, so make sure you sign up, follow along with our keynotes, and maybe even attend one of those workshops. Who knows?
There's going to be some really cool workshops there, and we're having multiple days. It's in EU daytime hours. I know at least half the people that I've seen in the workshop in the Discord are actually not from the US. So this is perfect time for you. It's free and a great way to pick up some new skills that will help you if you keep building infrastructure. So my name is Kerim Satirli.
And I'm DevOps Jacquie. I'm just kidding, my actual name's Jacquie. But it's been an absolute pleasure to get to talk to you today.
Before we dive into questions, just a quick heads up. What we showed you today, and you have a limited amount of time, so we wanted to show you one use case for Terraform. So if you compile your Go app and you want to run that on a server, that's what you can do now. If you want to run your web application, that's great. But Terraform can do a lot more amazing things.
You can do stuff like filing your expense reports every month to Expensify it, or maybe even ordering Domino's. It's more fun.
Like ordering pizza, yes. And see, I feel like you ordered many more pizzas during this hackathon than I did. And I feel like I haven't had the real... Exactly, that's...
But you've drank more Red Bulls.
Than I've had.
So I think between the two of us, we have like the hackathon food.
It's a hackathon experience, right? We need to get some stickers later.
I know, we would have brought them if it was in person, but that's okay.
Hey, so why don't you grab some questions from, I don't know, YouTube or Discord or both, and I'll bring up the material slide again so people don't have to remember hashi.co, whatever.
I don't even remember it already. Sounds good. So I'm just checking chat. I'm going to scroll through and see if there's any I didn't type to answer while we were speaking. I think there was a few. And then if anybody else has any more questions, feel free to drop them into, I was like, I'm going to point, but you can't see that. I've got the AWS workshop open over here, and I've got the YouTube chat over here.
I absolutely believe that you have those open. Quick note, if you have questions, we'll be here all weekend. I'll be online for at least another 2 hours, but you're definitely in good hands with Jacquie, who's in your time zone, which is very exciting. And if you have questions, the best place to ask is in the AWS workshop channel, because YouTube, once we stop our broadcast, actually kills the live chat, so we lose all the questions there.
This is true.
Which is why we don't kill the workshop, the broadcast right now. And we'll answer a few things live.
So the first question that I got is, I haven't scrolled all the way down to the bottom yet, I'm working on it, but was if we're planning on doing anything around importing resources and being able to actually import the resources from the cloud and have it work when they're, not Terraform.
Oh, that's cool. So it's not in our current workshop, but we definitely can share some slides about that. Importing is actually one of the more interesting things, because if you work in IT and you provision servers for a living, which is pretty much what DevOps engineers do, eventually you realize that something like Terraform makes sense, and you would want to bring the stuff that you previously created into Terraform. And so the Terraform import command works great for that. I'll share a link for that. Actually, I'm thinking we could possibly add that to the slides when we share them.
Yeah, we could do that.
With just a few examples, or expand the reading. That's probably going to be even easier.
Yeah, that's actually, you're right. That'd be better.
Because importing means a lot of copy pasting, making sure you have the right information, and just knowing where to go to get that information.
I think that's the only question that wasn't answered. I'll scroll through. Give it a couple more minutes just in case. But yeah.
So for you, what I'm wondering about, what are you going to do for the hackathon?
I'm not doing a hackathon yet. I put 100 hours into the last one. I kind of want to live a little. I'm just kidding. I can't leave my house. We're locked down for another 4 weeks. But yeah, probably no hackathons for the next little bit. But I am hoping. I don't think it's on webcam. But I have this giant pile of PC parts over here because I'm building a PC for the first time. So that's kind of my build a thing.
It's also a hackathon of sorts, right?
Yeah, it's kind of, hacking together some real pieces. Yeah.
And if you assemble them correctly, you get the grand prize, which is a kick-ass gaming PC.
Oh, did we finish uploading the slide deck, or is it just going to be at that URL and it's not uploaded yet?
I'm going to upload it whenever we're done with this. Okay. Maybe 3 to 5 minutes later.
Okay, should be up shortly.
So I think if you go there right now, it should give you a 4.4.
Yeah, somebody commented deck not found.
Yeah.
What else? Oh yeah, this is my first time doing a joint talk with anybody, so this is actually really fun. Kind of difficult, but fun.
It used to be a lot easier, right? Being in the same room and just speaking to people. Actually, having hackathons. I think for a lot of people, what I saw is there's this mixed bag of, pros and cons, right? Real hackathons mean you get to interact with real people in a single location, and you get to hang out, make friends, maybe explore the city, especially if you're doing any IoT stuff or maybe AR, augmented reality coding, then that can be a lot of fun. You go out, try out some things, come back and, get that grand prize. With a virtual hackathon, that's slightly different, but I think what's really cool, it's called Hack the Northeast, right?
Yes.
And it's a single region in the US, but we've seen people from all over the world joining this. And I think that impact is amazing. Like as an organizer, I would be super proud to have that kind of impact.
That'd be pretty
And it
neat.
shows, like there's a couple hundred people on Discord last time I checked.
272 online right now. Right.
That's what I mean.
So I misread the question. So the question was, this is the restate of it, is that Terraform resources can import state, but they can't create Terraform code from existing resources. Do we have any plans to create Terraform code based on existing resources?
Beautiful question. That's like one of the hardest things, right? You've got 100 servers, you want to get them into Terraform, and you definitely don't want to be copy pasting. So the ways SRE team actually built this tool called Terraformer, which if you give it your AWS credentials, it runs on your local machine, so it's totally safe. We'll go through your AWS account in whatever region you specify, or all the regions, and we'll create Terraform code for you. And that's a super good Kickstarter because it allows you to get out a lot of the basic copy pasting, and then you've got, pretty much like 60% done. Downside, it doesn't know variables. So for example, when you define an AMI ID and you have that same AMI ID for 100 servers, it will be hard-coded for 100 servers. Can happen, but that's honestly one of the easy things to fix. Like your IDE should make it maybe a 1-minute job to fix that across all those servers. I know internally we're looking, so internally in HashiCorp, we're looking at making this an even better experience, but it's a complicated topic. So for right now, Terraformer is, I think, definitely the best approach.
Oh yeah, I was nodding and then I remembered you can't see me because you're full screen. Oops. I think that's all we have for questions.
Awesome.
So.
Well, we'll definitely be in the workshop channel.
Yeah.
I'd say thank you so much once again for joining us today. We're super excited. And I just realized we're on YouTube, so it's not just the hackathon people that are joining us today, but also anyone else. But for all the hackathon contestants, we've seen a couple of the screenshots of what y'all are building, and there is some amazing stuff in there. So keep that energy, keep pushing, and just enjoy yourself. Thank you.
Thanks for coming out, everyone. And like you said, if you want to engage with us and you're one of the hackers, you can reach out to us in AWS Workshop on the Discord, or you can also reach out to us via Twitter or our other handles and stuff. Thanks, and have a nice day, whatever time it is for you.